Hello, Math Studies students. Welcome to another online lesson. We're continuing our unit on symbolic logic and our discussion on truth tables. Today I'm going to show you how to make truth tables for 3 variables. And I will talk about how to test the validity of logical arguments. So to start with, I have a logical statement written in symbolic form, which is not P and Q or R. And you'll notice here that we have 3 different propositions, all abbreviated by lowercase letters. So to start with, I'm going to write down those 3 letters, P, Q, R. We write them in alphabetical order. And since I have 3 propositions, that's going to be 2 to the power of 3, or 8 rows that I end up having. But you don't really need to remember that number. We just know that the row furthest to the right is going to be TF, TF. And that's what we would do if we just had 2 variables or 2 propositions. But we have an extra one, so we need to double it. So we'll have another TF, TF. Q here, the second one would normally be TF, TF. I'm sorry, TTFF, but again, we're doubling that. And the reason we're doubling all of these is so that now we can have our first one have 4 trues to go along with those combinations, and then 4 falses. All right, next we're going to look for a statement or things basically within the groups, and we've got not P and Q. Well, I'd love to compare not P and Q. I already have the Q, but I don't have a not P yet. So I'm going to make a negation of P, which is just the opposite of P, which started off with 4 trues. So I'm going to start with 4 falses, and then 4 trues. And now I should be able to compare that not P with Q, which was everything inside those parentheses that the green arrow is pointing to. So, and then if I want to just finish off my table here, once I have all of that, these parentheses, the not P and Q, I'll be able to compare that column using OR with R. So the setup here, I'm already done with most of the table. And so I'm looking for not P and Q. So that's this one right here, not P. I'm comparing that with Q right here. So you'll notice to start with, there's a T and an F, and this is an AND. In order for AND to be true, they have to both be true. So the first row just has 1 true. The second row, oops, that's a mistake. This is an AND. So in order for them to be true, they have to both be true. And there's only 1 true. So the first one's false, only 1 true in the second, so that's false. The next one has both false, so that's still false. And then finally we get to some trues. And then it's false, true, so those are both false. Again, and only when they're both true. Now we're comparing everything in the parentheses here, the not P and Q, and we're comparing that with column R, which was right over here. So we're comparing it with an OR. In order for OR to be true, all I need is 1 true, 1 or more. And the first one has that. The second one does not. Then yes, and then no. Then yes, 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 and no. And so that right there is our final truth column for this. It is not a valid statement because it is not a tautology with all trues. And that's truth tables with 3 premises or 3 propositions. All right, so this chapter has been leading up to this idea of arguments. We're not talking arguments like fighting with someone, but rather making your case, like a legal argument. And it's made up of premises, and premises are nothing more than essentially propositions, but they lead to a conclusion is the end result here. An argument is usually indicated by words like therefore and hence. And we always assume that the premises are true, at least for a mathematical argument. So you don't need to be thinking about whether or not the statement is true. And just like, as I've mentioned in other classes, you only have a true statement if it's a tautology on the truth table. So that's what we're looking for here. So I'm starting with some words, and we're going to try to relate this. So what conclusions can be resulted from emus can fly, Jane is an emu? Well, those would both be premises. It's sort of like if you ever watch a legal show on television, the attorney might say something like, well, you know, the suspect was at the scene of the crime and his fingerprints are on the weapon, therefore he is the assailant, or he is the murderer, something along those lines, where they make a bunch of statements and those statements then lead to this conclusion. So I've got these premises, these statements: emus can fly, Jane is an emu. What can we conclude from that? And emus can't fly and Jane is an emu, then Jane cannot fly. And that's what we show here. So now we're using another type of notation here, which is that premises go above this sort of line. It sort of looks like addition. And as we saw with things like the negation symbol and the and symbols, these are sort of related to other mathematics, whether it be probability or in this case just straight up arithmetic, where you put these things together, the premises, the P and the Q, and those end up reaching this conclusion here of R. So everything above the line is a premise, everything below the line is a conclusion, and we can turn that then into an argument by anything above the line gets separated by an and. The line itself turns into an implies symbol or an if-then symbol, and then everything after the line just gets written. So P happened and Q happened, therefore, or hence, or if-then, or implies, or however you want to refer to that symbol as, becomes R. And then we can make our truth table. If it becomes a tautology, it's a valid argument. So we're going to test this argument here. Premises. We have two premises. One premise is P or Q. Our second premise is Q. We have our line, which we read as therefore or hence. And then finally, our conclusion, which is the P. All of our premises get separated by an and. So I could start off with P or Q. I'm going to use parentheses to group them since they were one premise all by themselves. My other premise was Q. And like I said, I'm going to separate all my premises with and. You can have more than two premises. We have the P or Q as one premise. The Q is another one. I could have 4 or 5 more. Each one would get separated by an and. And then you have the line. The line we write as the therefore, which is also our if-then symbol and has the same logic truth table. And then our conclusion, which also can be multi-stepped and also can be joined with and, but in this case it's just a simple P. So P or Q and Q, therefore P. So now we need to make a truth table for that. Only two premises, P and Q. Then I need to go inside my group, which is P or Q. Then I'm going to combine the parentheses, the P or Q, and Q. And then I'm going to take everything, all of my premises, P or Q, and Q, and compare that with P, which I already have its own column for. So T, T, F, F, T, F, T, F. Now I'm comparing P or Q. In order for P or Q to be true, I just need to have at least one true. The first one has them both true. Then again, just one, and finally none. And the one with none gets a false. Now I'm comparing the P or Q, which is right here, with just Q, which is over here. And I'm using the and symbol for those. So that means in order to be true, they have to both be true. And you'll notice on the first row, they are both true. And then I just have one, and then they're both true again. And they're both false, which is not the same thing as both being true. So that one becomes false. And last but not least, I take this entire column here, which is all of this stuff right here, and I'm comparing it all the way back at the beginning with a P. I'll erase my other arrows to not confuse things any more than it may already be. And I'm using the implies or the if-then symbol. And notice I have to start with all my premises, which is over here. So I'm starting there, and then I'm finishing up with my then or my conclusion, which is the P column. So T followed by T becomes true. If I start with a false, anything that follows is automatically true. Here I started with a true, but I finish with a false, and that is no good for an if-then statement, so that's false. So then here again I start with a false, so automatically true. This is not a tautology because it's not all trues here in my final column. So this is not a valid argument. And that's it. We'll save that one for next class. And so our homework is on 244, 251. Also make sure that we are getting the project stuff uploaded, and we'll be talking more about that next time. Till then.